Good morning, guys. In the today's session, I'll take you to the tour of one more beautiful concept of Dbms, and it is very much useful even in industry and as well as especially when we are doing a project. We should know about this concept, guys. Right. So before starting today's session, guys, I'll take you. Will try to recall the things of previous session as what we have discussed in SQL queries of our last session. In the last session, we discussed about how to find out that aggregate, that means nesting of aggregate function, right? So that we are discussing. So how, especially what happens is when we directly go in finding a count of, for a count aggregate function, if I want to find out a maximum of that count, during the time max of, count of, writing of such nesting of such aggregate functions was not permitted in MySQL, right, that we have seen. Then how we can solve this problem? The problem, I think in the previous session we discussed about how to solve the problem of this nesting of aggregate function without finding, without knowing that nesting of this aggregate function. Definitely it is very difficult to write a query, right, solve such problems. So for that, what solution we did is we disguised, right, that compiler, SQL compiler. How we did MySQL compiler? What we did is first we have written a count kind of an aggregate function. We described with the help of this aliasing concept, right. So we renamed that count of some attribute ID, right, by a different name, and we have stored it in one temporary name by using again an aliasing concept, right. So and pushed that new name as what we have given for a query result, that it in a from class, and retrieve it from its outer query with the help of that what aliasing we have used for table name and as well as that count aggregate function. Once after that, that outer query doesn't treats it as an aggregate function, so for that it will be treated as a general attribute of the temporary name as what we have given for the query result, right. So from there we can apply, we are allowed to apply one more aggregate function and that the temporary table attribute, temporary table attribute, that is what we have pushed with the help of from class, right, with, by using the aliasing concept. So we would the beautiful usage of this aliasing concept, especially in nesting of aggregate functions in our previous session. So guys, in the today's session, I'll take you, I said one interesting concept. So could be you are more eager to know what exactly it is, right? So the concept is like this. Before entering into the today's topic, guys, I'll take you a small example. Most of the time, guys, we have seen that, especially when you see in the library or somewhere in the in the train or somewhere, what people will do is usually they'll read a newspaper. Even in our house also we have seen, right, the people will go through the newspaper. But especially the viewing of newspaper, it is not same by everyone, right. So that means how they will read, the reading style, it is definitely different from one person to another person. So people, could be possibility that you may find that you may feel that, so why is talking about newspaper reading, Yes, in our today's concept lies in that newspaper reading, I'll tell you. Especially when my father reading a newspaper, so people, let's say a few people might go with what reading of newspaper, they are much interested about the political things, right. They go through all the politics of the country, right. What happened to that Modi, what happened to Rahul, what happened to some other person, right. So Yediyurappa ji, like that they'll go through different things, right. That means they'll go to only political things, or what happened to that American election, right, like that, those things. Then few people, they are not interested about this politics. What they will do is they'll go to that sports section and they'll go through, they will view it what happened to the IPL match, right. So what match we are having today, what happened to that previous match, right, who hit maximum sixes, they could be interested. And even suppose if the possibility that few people only interested about cricket, though the sports section, that page, the last page, let's say 10th or 11th page, it contains sports information related to that tennis, cricket, football, many other things. But although they'll select only the cricket part and that only they view it, they go through it and they'll close. And few people might interested about only two things, politics and cinema. Let's assume politics, cinema and cricket, those three things, and they'll go through all these three things, and along with that we are having some economics information and many other things. They'll not go through such kind of a thing, right? This also be there. That means it's all about the interest, the people interest, right? So based on that they'll go through, though the paper consists of the things, the information related to economics, political science, many other things, right? So but although cinema, many areas, right, it contains, but people based on their interest, they'll select, they choose it, and they'll go through the things and they'll close it, right? So this is what the people will do. Most of the time will not go with reading a newspaper that is from the top to bottom by covering all different areas. Usually readers think that readers always go through the things in which based on their interest only, right? So actually I am talking about the same thing, that means the interest. Let's assume, guys, I am having a table here, that means a database where it contains 4 tables. So it contains an information related to movie, director, actor, act, right, many things. So most of the time we are not interested about all tables. Could be a possibility that we are interested about all tables and as well as all attributes. Our interest might be something what 3 attributes from first table and 1 attribute from a second table and 1 attribute from a third actor table and 2 attribute from a actor table, like the fourth table and so on, right? Or could be a possibility that only from these 2 tables I want to retrieve few things by considering 2-3 tables, right, like that. That means especially when you are doing a project, guys, if it based on the problem statement, suppose let's assume my project consists of my project database design, where the database consists of around hundreds of tables. Usually will try to retrieve an information from more than 10-15 tables. During that time, if I want to write a query by using 10 to 15 tables, then I want to write all 10-15 tables names in the from class, and I should write a joining condition, the common attribute joining condition between all the tables, right? So then after that we'll go with retrieving our required or our interested attribute, right, as what we want. So especially if I want to write such query and the same query as what we have written, the result of that query as what we'll write, if it is required, so multiple times in my project, right, at different locations, at different scenarios during that time. So do you think that writing of a same query by using those 10-15 tables as what I said, by typing all 10-15 joining conditions, definitely it becomes very costly, right, writing such a huge query, right? Then in that return result we'll add few things to, that means based on some condition or a problem statement, right, as what we are having, based on that the return result will add a few things, additional conditions, and will retrieve the things. So instead of suppose if it required 10 times, assume 10 to 15 tables, so that 10 to 15 joining conditions, then I want to use it 15 times, assume. During that every 15 times, whether you will go with writing such a raw query again and again, such a huge query, definitely that becomes very costly. Instead of that, what's the best thing we can do is, can we write query once by considering all 15 tables, by joining all 15 tables, right? Then after that have all the interested attributes for all 15 occasions, right, situations in which we want that query, retrieve all such interested attribute and save it in one name, right? And whenever you want, you make use of that name, right? So save it in a temporary table, you can consider temporary virtual table, then retrieve from the temporary virtual table as what you have created. So for that, so no need to write all 15 table names and same joining condition where so and so t1 dot some attribute name equal to t2 dot some attribute name. Definitely that's a very tedious task, right? Instead of that, give some name as some v1 for that. Depending on a user interest, you can give any name. Then writing select star from v1. This is simple, where I can get the attributes, all interested attributes as what I have listed from all 15 tables. I'll get it just with an writing just from v1. That's it. And what name I have given for the query result, right? That virtual table. Actually what I am talking, I said in huge 10-15 sheets of newspaper, we'll read it only 3 sheets, right, based on our interest. Here also same thing, I am having 10-15 tables. So out of this 10 or hundreds of tables, I'll select only 4-5 tables or 10-15 tables, right. Again here 4 tables, I'll choose only interested attribute, though I am having hundreds of attributes here, right. So it all depends on our interest, and I'll call it by small name, and every time when I want, I'll just go to that name, the table virtual name as what I have given for that query, and I'll retrieve the things, right. I'll check some conditions on that. That means we are talking about it is based on their interest and based on their views, right. Yes, in the today's concept, actually I am talking about views in SQL. Views means a virtual table. Definitely few of my friends might feel like this. Sir, I am having a out of 100 tables, have retrieved the attributes from 15 table, assume. Then you are saying save it in a temporary table. Saving it in a temporary table, again, it doesn't become a memory efficient, right. This is what I think we are having in our mind, because already I have stored a data in 10 tables, then again pick interested attributes. Let's say here out of 4 attributes, I want movie name, I want language, and who is the director, and who are all the actors acted in that movie, right. So only such, and in what role they are acting. What I want is movie list, and it belongs to which language and in what year it was released. I am not interested about movie ID, then director ID, all such things I don't want. What I want is movie name, what's the language, and what is the release year, and who is the director. I am not interested about the age of the director, and I am interested about the actor name, and that actor acted in which role. That means to solve this query, I want to connect all the 4 tables, Yes, definitely I need to connect all 4 tables, but I am interested about only name, language, release year, director name, then actor name, then role. So 1, 2, 3, 4, 5 and 6. I am interested about only 6 attributes. Total, how many attributes I am having? 3 plus 2, 5 plus 3, 8, 8 plus 2, 10, 10 plus 3, 13. Out of these 13 attributes from the 4 tables, I am interested about only 6 attributes. Let's say I want to display that one, and many occasions, many situations might be there in my project. So for that, based on these 6 attributes, I want to check many other conditions. So when I want to retrieve these 6 attributes, usually what we'll do is, it is required to join all these 4 tables, right. So based on some joining condition with the help of these foreign keys, see, based on this DID, join these 2 tables, then based on this AID, join this table, right. Then MID, so I missed one more thing, this is MID, right, and this one, this MID pointing to the movie table MID, so that this actor acted in this movie and in which role, right. So based on this selected 6 attributes, I'll go with writing many queries. So for that, if I want to make use this 10 different situations in my project, then whether you go with writing this query again 10 times by joining all these 4 tables again and again, writing same condition, definitely that becomes very costly. So this 6 I said, it is my view, my interest, right. So here also what I'll do is, out of this I'll choose this 6 and I'll give some name for this. Definitely it consists of 6 attributes I said, right. So let's say 6 attributes I'm having. So what are all the attributes I said? I am interested about name, I am interested about language, and I said I am interested about release year, then I want D name, then I want role. So these 6 attributes, then actor name, right, who acted, let's say actor name, then followed by the role. Then I said store it in a temporary table. Temporary means don't go for creating a new table. Suppose if I say, most of the people might think like this, temporary table means, sir, whether we'll go with creating a same table again, so one more table and storing all these attribute values. Let's say I'm having hundreds of movies and hundreds of directors and hundreds of actors. So all such information whether to store again and again here, then definitely that becomes very costly, because same data if I want to store it in a one more location, so that definitely will not be treated as a memory efficient answer, right. So what is the best thing we can do? And one more problem what we will find from this is, though if we, because we are not worried about memory in the today's scenario, right. So because it is available very less cost, but when I store the same thing in a one more table, that means I am talking about people will suppose if they say, sir, we are not bothered about memory, but still it's having a one more problem. What is that? Data inconsistency. Suppose if any movie updations release here or language something, if any new changes, whatever we made, or any new movies if it is added, directors added, or any changes what we made here, any updations, whether it will be reflected in this temporary table as what we have created now, just now? No, because every time when I want to input here any updations as if I made on these attributes as what we have listed here, then again I want to make a changes here also. So that if it doesn't reflect here, then that we call by name data inconsistency, because this contains a different values and this contains a different values, right. So again how we can solve, that means creating a temporary table that doesn't becomes a solve, that doesn't solve our problem, because it suffers from memory inefficiency, right. That means it consumes more memory, then it is not memory efficient answer. That's what I want to convey you here. Then after that it is suffering from one more problem called data inconsistency. So what can, definitely I want these kind of a view, and I want to give some name as what I said. So T1, T2, something as whatever you want. Then afterwards write select star from T1, suddenly it should give me this value, right. So to get these 6 attributes, I have written one query, right. Let's say query, I have written one query, and for this query I have given, this is the result of query with some data. Let's assume I am having some data for this query under this is the result of this query, because to get this I have written a query and the name given to that query is T1, right. T1, name given to a query is a T1, yes. What I will do is, guys, instead of, I will go with creating a temporary table, no, instead of going for creating a temporary table, what kind of a temporary table, yes, I want definitely a temporary table, but what kind of temporary table I want is, it should be a virtual table, virtual temporary table. Definitely a few my friends might think like this, sir, temporary table means once after its execution, let's say I will close my SQL, then again when I relog in, then the temporary table will be vanished? No. So what kind of a table I want to create is, I want to create a virtual table. That means the table should not be existing, but it should give a feeling for us the table is existing, right, like that. It's an indication that we'll go for writing one query by retrieving, by connecting, by joining all these 4 tables, we'll write one query and we'll give some name for that query, right, and we'll store this query. Look at this one, store the query in SQL. Storing such a huge data, if I am having a lax together movies, then storing that lax together movie data, that becomes costly once again in a temporary table. Instead of that, what I am doing is, I will write one query by joining all these 4 tables and I will store this query, not the data. Look at this one, already data is saved once, right, but I am storing only the query, right. So, and we are giving one name to that query. Till now we are not saving a query, but this time what we are doing is, we will pick all interested attribute from the tables from the query by writing one query, and we are saving that query with some name. We are giving some name for a query, right. How we give a name for a table, in the same fashion we will go for naming a query also, right, and storing that query. So storing a query is consumes very less memory, right. So occupies very less memory when compared to storing the same data again, right. And whenever I go, I want to call this query, when I want to re-execute this query, then what I will do is select star from T1, or whichever attribute you want, you can write it. When I say from T1, in the place of T1, it replaces the whole query here, that's it. Already in the previous session we have seen that in the from class, even we can able to write one more query, right. that we have seen, right? Here also same thing will happen. In place of T1, we have stored one query and the whole query comes at this position, that's it. So it's an indication that it gives a feeling that we are having one table in the name of T1, but actually we don't have a table in the name of T1. Instead, T1 pointing to a query, and that query contains the attributes from different tables based on the interest as what we have seen, as what we have written, right? So that this we called by name, but it gives a feeling that, oh, there is a table like T1, but actually no such table here. Do we have a T1 here? No. T1 is a name given to a query. So for that, this concept we called by name, it's a virtual table, and this is a virtual table created based on for our interest, right? So which are all the attributes are required, again and again retrieve all such attributes and create one query, right? One view, then that means a virtual table, then go with writing of a query on that view, right? So for that we can hide. So when I say select star from T1, so it is difficult to know that. That means the person will not come to know that, even it's a secured one also. That's what I am talking. That means when we say select star from T1, it doesn't know about what the T1 contains. That means T1 is created. T1 is a view created by using which are all the tables, right? So that will not be known to that person. So for that only he knows. That means if you want to concise a view, that means to a person, if you want to give only 6 attributes to for further development or to solve some problem, instead of giving an access to all 6 attributes, only create one view, right? Some T1 and give that view to write queries. That's it, right? And few of my friends might have a question like this: sir, in case of virtual table, that means in case of views, how we can achieve a data with respect to memory data consistency? That means we said memory efficient wise, this concept, instead of creating a temporary table, this is more efficient, we said, because storing of a query is better when compared to a storing of a one more time the same data. That means with the help of temporary table, right? So for that, writing of view with respect to memory efficiency wise, memory wise, it is very important, very better, very good result. It yields us a very good result, right? Becomes a very good solution. But in case of data consistency, there also it plays a major role. That means what, it is more efficient. How we can achieve data consistency? Because since we are not storing that same data again, only we are storing a query, right? When you go with writing select star from T1, then when you press a enter, then what happens? This T1 will be replaced by this query and the whole thing will be re-executed. When it goes with re-execution, anyway we have seen that when we go with re-executing a query, though any updations we made on these tables, then definitely the query reflects, that will be reflected in the query. Here also same thing. When we go with re-executing of a query, since things will not be stored here, that means in a separate location, so this query always executed. That means this always plays, always it will be executed based on this table data, that's it. So for that, it doesn't suffer from any data inconsistency, right? So data as what we obtain here, it's always consistent. Any changes made here, definitely during this re-execution, that will be reflected. That's it, right? So for that, the problems as what we are having with respect to data inconsistency and as well with respect to this creating a temporary table, what are the problems we are facing? One is it takes again a huge amount of memory. Then second one is data inconsistency, and both the problems are solved with the help of this virtual tables. That means storing of a query, it is better instead of going with creating a temporary table, right? But it should give us a virtual feeling that there is an existence of a table in the name of some T1, T2 and so on, right? Based on as what name we have given. So the question is how to create it, and few people might think that, sir, whether to make use of all 4 tables? No, not like that. It depends on the problem scenario as what requirement you are having. Based on that, you can join as many tables as you want and create one view and use whenever you want, right? And wherever you want. This is what the beauty of the thing, right? So now we'll go with creating such views, right? We'll try to explore it practically. So based on this, guys, we'll try to take up one small problem statement. Let's assume I want to retrieve the attributes as what I said, movie details. There it should, I want movie name, language, director name, not the age, then actor name and the role played by that actor, right? So all 4 tables I want, and I want all those 6 attributes as I said. So let me write. I don't want to store it physically once again. Instead I want to store it in a view, that means in terms of a query. For timing, I'll write m name, language, release year. So there is problem with respect to space. So for that, I'll write the attribute names only here. What all the attributes I want in my view is m name, this is the interested attribute, language, release year, then actor name, role and the director name. These 6 attributes I want to list it again and again, and I want to write some query in future, right? So for that I want to have one view where it contains these 4 attributes. To do that, guys, let me take you to the MySQL. Look at this one, guys. I am having already a table. That's a database, Cinema DB, where it contains act, actor, director, movie, and movie table. This is what data I am having. So I am having 4 movies, right? Then after this I am having actor details here. Then these are all the director details, and these are all act details. Which actor acted in which movie and in which role, right? All such data I am having. So definitely to create a view, what is required is we need to write one query. That means writing of a view means it is not physically storing the same data again, instead storing of a query, but it should give a feeling of virtual table, right? It is retrieving from a table, right? So guys, let me go with writing one query. That means even for writing a view also, it is required to know how to write a query. So for that, give more importance for a query, right? That means once if we know, if we are good enough in writing of queries, then definitely all these concepts becomes very simple, right? That's it. So let me go with writing of a query. Then how can I retrieve all these 5 attributes, 6 attributes, guys? Movie name, language, what I want, which all the movies are there, belongs to which language, and released in which year, then who is the director and who are all the actors and in which role they have acted, right? So such information I want. To get all these things, which all the tables are required? I want movie, I want director, I want actor, and I want act. All 4 tables are required. So let me go with writing a query here. I want movie M, then I want director, then I want actor, then act. Both will become same name. Let me call it by name AC. Few people might think that, sir, why to create a view? Anyway, it is just a query, again we'll write it. If you want to write it, that becomes again writing a big query. That also becomes costly, So for that also will be avoided with the help of these views, right? Fine. So where to write this all 4 table? Always to be written in a from class, right? Let me write it in a from class. Fine. So what all the interested attribute I want to retrieve? Movie name. Let me write M name. Next what? Language. So M name, it is from which table? Movie table. Movie means what? M. M dot M name. Next what? I want language. Language also present where? It is also present in movie table, right? Movie means M. M dot language. Fine. Then after this, release year I want, because these 2 are over. Then release year. Release year also obtained from movie. Movie means M. M dot release year. Fine. What else I want? Next, actor name. Actor name, let's say first director, whichever you want, director name. To get a director name, director D name, D dot D name, you can write. Next, what other attributes I want? I want actor name. Actor from actor table. Actor means A dot A name. Next, I want the role played by the actor, right? So this is what the last one. Role present in act table. Act means AC dot role. Fine. So writing this much itself is enough? No, because when I write only this much, this becomes what? A Cartesian product. That means tuple multiplication is going to happen. Once if tuple multiplication is going to happen, then what happens? It contains plenty of spurious tuples, right? So unwanted, unmatching tuples, right? So everything will be listed, right? Though it doesn't matches, that also be listed, right? By multiplying, right? With the tuples between the tables. That's it. So for that, never forget of writing a joining attribute condition, right? Common attribute joining condition. What's that, guys? How can I join movie with a director? Is there a relation? Definitely. This movie directed by who? I'll get it with this director ID. This director ID says to join this with this director table, make use of this movie dot director ID with director dot DID. So let me go with writing yum dot DID should be equal to what? D dot DID. That's it. Now these two are joined, right? Connected. What's the next one? Next one is to know in this movie who are all acted. This movie, that means contains which all the actors, because I got the director details, movie and director details. I want to know who are all acted in this movie. To get this, it takes this MID to where, guys? To the actor table. Then act table contains movie ID and actor ID. So for that, join movie.mid with act.mid so that I'll get a AID, and when I take this AID and it takes me to an actor table, and from actor table retrieve the actor name. I can get actor details and their respective roles also here, right? So what next to be done? Movie.mid should be equal to act.mid. Movie means what? Yum.mid should be equal to what? Actor, not act, because directly cannot connect. Act, is there a relationship with actor to movie directly? There's no direct relation, it's an indirect relation, right? Like this. So for that, movie.mid with act.mid. Act means what? AC.mid. Fine. I'll get the role with actor ID, but I want to know their names. How can I get? Act.aid should be equal to actor.aid. So that act means what? AC.aid should be equal to what? Actor. Actor.aid. A.aid, because actor means what? A. So all three conditions must satisfy, then only we need to retrieve. Then what to do, guys? So write and common attribute, because this also must be true, this also must satisfy, and this also satisfy. So for that, so make use of what? And that's it. This and this and this, all conditions must satisfy. Put a semicolon, that's it. This executes me a query, guys, that's it. Then once if it is executed, once after logout, again if I want to write this query 100 times, let's assume, during that time, what to do? Again go on typing select star from table name, m name, from movie, director, and writing all these conditions again and again 100 times becomes very costly. What's the best thing we can do, guys? Save this query, whole query block, save whole query block, right? So with some name, save the whole query block with some name. How So retrieving, where to write? Again, I missed. What is that? Select. So what we can do here is store this query with some name. Let's say I said V1. You can give any name, no issues, right? And I said this V1 is a name given to a query. V1 means we are saying it gives a feeling of a table. What kind of a table? Virtual table. Virtual table means what? views in SQL, right? So for that V1, I want to create this V1. So when I want to create anything, if I want to create in SQL, we are using a keyword like create. Create what? Create view. Create view. In the name of what? V1. And V1 should contain what? This query. V1 as this one, guys, this query. That's it. Then this V1 will be created, where it contains these 6 attributes. Now onwards, if I want to access these attributes, these details, then no need to go with joining all these 4 tables. Instead of dealing with directly with these tables, what I can do is just make use of this V1 and build whatever query you want, right? So actually we are dealing with this V1 indirectly, means we are accessing V1 means indirectly we are accessing what? These table data only. That's it, right? Because behind this V1 what we are having? These 4 tables only. That's it. So for that, writing all these conditions and writing all these table names, that all becomes what? Reduced, that all will be reduced. Easily I can get select star from V1, that's it, or select M name from V1, select M name comma actor name from V1, those things, or retrieve all movie details, actor details, director details of all the movies which are all released in the year 2020, suppose if it is asked. So what you will do? Write all it, because to solve this query all 4 tables are required. You will write the whole same query and one more condition. What is that? And because it retrieves all movies, though it was not released in the year 2020, instead of writing a same query and release year 2020, what to write is select star from V1, where since we are having a release year here, right, where V1 dot release year, because afterwards this will be called as what? V1 dot release year, because this belongs to now onwards to which one? V1 dot release year equal to 2020. That's it. Fine. So this is how we can able to write, right? Create a view. We'll go with exploring how to create a view and how it will be saved. Really it stores it virtually or not, right? So, and can we achieve a data inconsistency? All such things we'll explore it now. I said I want tables. Which all the tables I want? 1 minute. I want movie table. Let me write from movie yes. What else I want, guys? I want director. Let me write director D. Next, I want act and actor. Act AC and actor A. You can give any name, no issues, aliasing, that's it. Where what? We have written all 4 attributes. Then after this, before that, let me go with writing what all the attributes, intested attributes, right? What are all my weaving attributes, right? So let me write. So what are all? Movie name. Movie name obtained from where? Movie table. Movie means what? Here M, right? So M dot M name. Fine. What's the next one? Language. Language obtained from where? Movie table. Movie means what? M. That's it. M dot language. So, fine. Next. What's the next attribute? Release year. Release year present where, guys? It is in movie. Movie means what? Again M. I can write M dot or year. Release year. What's the next one? D name. You can write whichever you want. Actor name and D name. Because one movie having only one director, this is what our assumption. Then, but one movie contains many actors. So for that I'll retrieve that actor at the end, right? I'll write that actor name at the end. If you want, you can write it now only, no issues. Let me write D name, whichever order you want, you can make use. So director name. So it is from which table? From director table. So let me go with director means what? Director means D, right? So D dot D dot D name. Fine. What's the next step? I want actor name and their role. Actor name present where? In the actor table. So actor means what? A. You give a name in the aliasing. Actor means actor A, right? So that, let me write A dot A name. Fine. Next, I want the role. Role is present where? In the actor table. Act means what? AC. AC dot role. That's it. Then what's the next step? When I say write only this much, then what happens? Look at this one. Plenty of data will be retrieved. Why? So it is showing me 288 rows are present. Actually, do we have 288 rows? Even when I go with considering all the table data, then also we won't get all these 288 movies or 288 directors or 288 actors. We don't have. Although why we are getting all these things? Because there's a tuple multiplication happened, right? So for that, what's the next step? To avoid it, what to do? Right? Joining attribute condition. What is that? Where m dot mid should be m dot did should be equal to what? Director dot did. M dot did should be equal to what? Director dot did. And one more. What is that? Actor dot m dot mid should be equal to act dot mid. M dot mid should be equal to act means AC. AC dot mid. Yes, 3 tables are joined. Next, the left out table is actor. To get their name, act dot aid should be equal to actor dot aid. Act means AC. AC dot aid should be equal to what? A dot aid. That's it. Fine. We got the data. Is it right? Let me check. Select star from movie. So I'm having 4 movies. And it should display only 4 rows, No. Why? Because though we are having 4 movies, but we are having a more number of actors. Let's say select star from director and actor. Director, actor and actor. So how many rows is the right answer? Let me check. We are having 4 movies. Yes. 4 movies having 4, definitely it should display me 4 directors, okay. Then along with that, in each movie 1, 2, 3, 4, how many actors are acted, right? So that I want to find out. So these are the movies and these are the actor edits, and in which are all roles they have acted. So what is the actual amount of rows it should display? Actually it should display me, so how many actors acted in each role, for every one it should display me a 1 row. Right, and it will be connected with that particular row of that movie ID, and it should display me a movie name and movie ID respective director name it should display. So for that it contains 3, 6, 8 actors, either few actors with same role under different movies, that also be there, are different roles in different movie. So 3 plus 3 6, 6 plus 2 8. So how many rows our query is displaying? 3 plus 3 6, 6 plus 2 8. One particular sample will take up, guys, what is right or wrong. So ABC Kannada 2020, ABC Kannada 2020, movie ID 1, DID 10. 10 means what? Rajesh. Whether we are getting in our query, let me check. This is our query. ABC Kannada 2020 Rajesh. Fine. Who are all the actors acted in that? Let me check. AID, that is MID 1, right? 1, 2 actors, 100 and 101. What their name? 100 and 101. Ajay and Babu, right? So it is in the role of hero and hero, right? That only. Let me check. So Ajay, Rajay here. The movie name is ABC, fine. Kannada, 2020, right? Rajesh, this one is the director name, fine. Next, Ajay and Babu, fine. Hero, our data is right. Now, once after this, we don't have this weave, guys. Now I want to create, actually it's a query, that's it. If once again, if it is required, again you have to retype the whole query. Instead of that, what I said, give some name for this query, I said, right? That becomes a virtual table. Here also same thing I'll do. What I'll do is, I'll call the whole query with some name. Let me call my name V1, I said, V1 as this one. And I want to create weave, it's a weave, right? V1 as this data, as with this query, that's it. That's it. Now let me write enter. What I get? Query okay, 0 rows affected. But earlier it is giving me an answer, but now no answer is displaying. So then what to do? That means this query was saved in the name of V1. That's it, guys. Right? You want show tables. Look at this one, guys. I said it creates me, actually it's storing a weave, storing a query, but it's giving me a virtual a feeling that there is a table existing in the name of V1. But the table was not physically existing, it is virtually existing, right? So for that, it will be listed in the table list, right? So, but it is actually a weave. To get it, how to access a table, guys? That means I said it should give me a virtual feeling of a table. Usually how we can access a data from a table, let's say from a movie, if I want to access, what we'll do is select star from movie, right? Yes. But in the same fashion, if I want to access it from V1, that is because V1 is listed, I said it gives a feeling like a table, right? But physically it was not saved. Here also same thing. Look at this one. Actually the same data will not be saved. If it is not again saved, no, it was not saved. It was only only query is saved. That's it. Query is re-executing every time when we go with calling this V1. That's it. So for that, one problem is solved. That means we said it's a virtual table. But data consistency, where it is there, we'll check. Suppose if it is saved in a separate location, then any changes made here that will not be reflected here, right? So in the virtual table. Suppose if it is physically existing separately, right? So since only query is saved, the query once if it re-executes, definitely it reflects. So let me check that one. That we call by name data consistency check, right? So let me do that one. Let's say for example, I'll change the release year of ABC movie to 2019 or 1998. Let me check. Update. Which one? Release year is present where, guys? In the movie. Update movie and set release year to 2019 where M name equal to ABC movie name, right? So that one. Yes, updated. Let me check in movie. Yes, movie name ABC 2019. Definitely we know that it happens because we are making changes in updation in a movie table so that it is reflected in movie. Nothing big in that. But is it reflects in our virtual table? As what we are saying, it is virtually existing and it holds the data consistency. Let me check, guys. So ABC 2019, we are having ABC 2019 so that it's reflected. Any queries, any questions you are having? So could be my friends, few of my friends might think that, sir, since it is a table, giving like a virtual feeling like a table, so that how we retrieve the things from a table in the same fashion, even from a weave also we are retrieving. So definitely it is giving us a virtual feeling of a table, fine. But the question is, can we update, let's say for example, anyway it is looking like a table, so that how we update a table like movie, movie release year to 2019 something. So even V1 also contains a release year, so that with the help of this V1, can we update that movie? That means any changes made here, that is on the V1, whether it will be reflected in movie. Let me check, guys. So could be, you might have this kind of a question, right? So let me explore. Update, what guys? V1 set. Let me change this from PQR is there, PQR from Hindi to Kannada. Let me check. Update set. What language? You can change any attribute you want. Equal to English or Kannada, anything you want, you change. Language equal to English, where M name equal to what we said, PQR, right? 2 rows as the expected rows to be affected, right? So PQR. Any guesses? Effects or not? Let me see. Query, okay. Oh, it is okay. That means it was updated. Let me check, guys, whether data was reflected or not. V1, yes, we updated in V1. So PQR changed to English. But whether it happened reflected in movie, we'll see the corresponding values in the movie table. So there also PQR English changed, right? So definitely it gives a feeling of a table, but it is not physically existing. Instead, it's the query behind a view that will be saved. And every time when you call a view, that goes for re-execution of that query. That's it, right? Where it avoids the retyping of such a huge big query with multiple joining conditions, that all will be reduced. And if you want, you can do some filtering, you can querying with this table, because it look like a table only, So V1, where only movies released in 2020, where R year should be equal to 2020. I can write. That's it. I can get, it is retrieved from V1. If I want to retrieve all this data of released year 2020, then again I should write a whole big query. Instead of that, easily we can solve with single line, right? So this is what a beauty of views, guys, right? So in the tomorrow, we'll continue our discussion on views, right? So try to explore this views, right? Views concept, right? Thank you, guys. Thanks for your patience listening.